Hi everybody, welcome back to section 2.5. In this video, we're going to go ahead and solve a Bernoulli equation. So, here in example 1, we have x times dy over dx plus y equals x squared y squared. So this is a Bernoulli equation, and a good giveaway is that y squared attached to the x squared. Okay, remember y needs to be in some power on that right-hand side. But let's go ahead and try and solve this, okay? So remember the step-by-step methods that we previously talked about. So step 0 is always making sure we're in standard form and having that derivative dy over dx naked. So here I'll say step 0, get dy over dx naked. So what we're going to do is just divide x to both sides to get dy over dx naked. So if I divide by x, what I would get is dy over dx plus y over x equals x squared y squared over x. And then x cancel out, and then we could just rewrite it a little bit to clean it up. Dy over dx plus, I'm going to bring the 1 over x in front of the y just to give us a clear view on what our functions are, equals x y squared. Okay, so we are in now standard Bernoulli form. Okay. And notice that now that 2 gives us our n equals 2. Okay, so let's go ahead and keep moving along the line. So step 1 is where we start setting up for our substitution. So here I'll say step 1 is when we set u equals to y to the 1 minus n, and we want to solve for y and our derivative dy over dx. Okay, so we know n equals 2, so let's go ahead and check that out. So we let u equal y to the 1 minus n, which is going to be 2. And so we solve for this now. This would be u equals y to the negative 1. And then we could just move y to negative 1 down into the denominator to make it a little easy to work with for our algebra. This is u equals 1 over y. Okay, so when we, in step 1, start to set up our substitution terms, we have to do two things. We have to use calculus and we have to use algebra. So let's look at algebra first. Okay, so we found u to equal 1 over y, and I'm going to use some algebra to solve for y. So if I solve for y, we just reciprocate and we get u 1 over u. So y equals 1 over u. Okay, that's my algebra. I'm going to use this to substitute into the differential equation in a second. That's the point of this. And we're going to use calculus as well. And by that, we mean take a derivative. So if we take a derivative of y, so dy over dx, well, the derivative of 1 over u becomes 1 over u squared du over dx. So now I have my y, I have my dy, and now I could substitute back into the differential equation to put this in terms of x and u. So step 2, substitute back into the differential equation. So our differential equation from up above is dy over dx plus 1 over x y equals x y squared. So we're going to substitute in y and dy over dx into this differential equation. So this would be negative 1 over u squared du over dx plus 1 over x times y, which we found to be 1 over u, equals x times y squared, and y is 1 over u, so 1 over u squared. Okay, so that's us substituting into terms of x and y. So let's clean this up a bit. Let's take away the parentheses. Let's square that 1 over u. And what we end up with is 1 over u squared du over dx plus, I'm going to keep these separate still, 1 over x times 1 over u equals x times 1 over u squared. I'm going to keep some things separate. Okay, so we've substituted, and now the third step we're going to do is utilize our linear equation method and solve it like a linear equation. Okay, so step 3, we'll call that linear equation time. Okay, so here I have our differential equation, negative 1 over u squared du over dx plus 1 over x times 1 over u equals x times 1 over u squared. Okay, so linear equations, the first thing we always do, much like we did in step 0 here, is get our derivative naked. So here I'll say get du over dx naked. So what I'm going to do is multiply both sides by negative u squared to get my derivative du over dx naked. So this cancels out. And so what we end up with, u squared here cancels out, is negative, excuse me, would be du over dx minus 1 over x, because this u would cancel out and we'd be left with just a u equals negative x on the right-hand side. Okay, so now we have a linear equation. Remember, a linear equation is dy over dx plus p of x y equals q of x, right? Well, now we have this linear equation, and 1 over x is my p of x, and x is my q of x. So one thing that always is a good indicator that we're doing this right is this power of u right here. So let's make a note of that, like, key. If you did it right, you should get just the single power u to the first power. Okay, so that's a good indicator of doing this problem right so far is that we're just getting u to the power of 1. Okay, if you're getting u squared or square root of u or something, and it's not just due to the first power, something went wrong. Okay, so this is a good indicator. Okay, so we have a linear equation, and so uh, how do we solve a linear equation? Well, we need to get the integrating factor and then multiply it to both sides. So that's our next step, getting an integrating factor. So I'm going to come back up here, up to the top. Let's sort of cut this off a bit, give us some room. Okay, so coming up to the top, we need the integrating factor. So integrating factor, remember it's mu of x equals e to the integral of p of x d of x. Okay, so what is our p of x again? Let's scroll down to the bottom. Well, that is -1 over x. So let's go ahead and find that integrating factor. So this would be mu of x equals e to the integral of -1 over x dx. And so the integral of -1 over x is natural log. So negative natural log absolute value of x. One thing we could do is bring that exponent up, properties of logs, and we get e to the natural log absolute value of x to the -1. And the e and natural log cancel out. And so we are really just left with x to the -1, and we can turn that into 1 over x. So that's our integrating factor. So what do we do with our integrating factor? We multiply both sides by the integrating factor. Okay, we're in linear equation mode now, remember. And so we're going to multiply 1 over x times our differential equation down here below. So multiplying the integrating factor to our differential equation, what we get is 1 over x times du over dx minus 1 over x u, close that off, and then negative x times our integrating factor. Okay, so when we multiply this through, our right-hand side cancels out. We're just left with a -1 there. But what we get is 1 over x du over dx minus 1 over x squared u equals -1. Okay, so remember with a linear equation, we want to make sure we're getting a product rule. We're getting a derivative of a product. Derivative of product. So let's look at it like this. If I have 1 over x du over dx plus -1 over x squared times u equals -1. Well, this is a derivative of a product with the product rule. So this would be f. This would be g prime. This would be f prime. This would be g. And so this is a derivative of a product. So what this is essentially is a derivative d over dx of 1 over x times u. Now remember, this is my f and that's my g. And so when we have this derivative of a product, what we then do is integrate both sides. So we're going to integrate both sides. And the reason we do that is because the integration and derivative cancel each other out. And so what we're left with is 1 over x times u equals the integral of -1 is just negative x, and then we add our plus c. And then what we want to do is solve for u. And so u would be negative x squared plus cx if I multiply x to both sides. And so I have u equals negative x squared plus c. So we have our solution, but we're not there yet because our last step is putting this back into terms of y. So here I'll say step 4, substitute back in, or say back in y. We're just going to substitute y back in. So note that we have u equals 1 over y. So if I plug back in 1 over y for u, what we get is 1 over y equals negative x squared plus c times x. And so let's go ahead and solve for y now. So if I multiply y to both sides, I get 1 equals negative x squared plus cx times y. But I still want to solve for y, so I'll divide both sides by negative x squared plus cx. Let me make a note of this. Okay. And what I'm left with is going to rearrange it now, but it will be y equals 1 over negative x squared plus cx. And that is our answer. Okay. So that's our answer. We do have a rational answer. So one thing we have to be careful with here is our interval of solution. So to finish this off, let's clean up that interval of solution. So, interval of solution. We have a rational answer. So let's see when our denominator equals 0. Okay, so interval of solution. Let's try to solve for this. We'll take out an x, so it'll be negative x plus c inside. We set both of them equal to 0. And so x equals 0 is 1, and then x equals c is the other. So the interval of solution is all real numbers except x equals 0 and x equals c. Okay, so this is good for a final answer, but I like to clean it up a bit. So here I'll say, therefore, y equals negative 1 x squared plus, 1 over negative x squared plus cx. And the interval of solution would be all real numbers. X can equal 0 and x can't equal c. And that's the answer. Okay, so like we were saying before, these problems are quite long. So we take the linear equation method and take it up a notch. So this is quite a long problem. So make sure you're doing the steps right and getting a final solution y equals something on the right hand side or left hand side. And just like a good indicator is that if we're just getting u to the first power when we start that linear equation time, that means you have done this correctly. Okay, so that's a good indicator. If you're not getting u, then something went wrong. You want to go back. But yeah, these problems take a while. Make sure your step-by-steps are good. But that's it for this video. We'll try a couple more, and I'll see you in those videos. Okay, take care.